So I'm just going to kind of give you the highlights, the anatomy of we call it a hurricane, but really it's a tropical cyclone would be the more generic name. So from satellite images, we can actually see those clouds. That underneath those clouds, there's a fair bit of precipitation, and actually, that's one of the deadly parts of a hurricane is the precipitation. So that we call them spiral rain bands. And then in the eye of the hurricane, it's pretty complicated because, like you can see from this description, in the eye of the hurricane, at the surface, we have a low pressure, and so actually, that would be what cyclonic movement, so the air would be going counterclockwise at the surface. And so one of the things we know about lows is that air will be kind of converging there. And in order to sustain a low, we've talked earlier that actually that meeting air is going to build up. And so we need to have divergence aloft at upper elevations. But with a hurricane, we don't have that divergence. So where you have your low, how do I say this? At upper elevations, this is the eye. At upper elevations, we have a building high pressure. And actually, it's that kind of high is characteristic of a hurricane, and it's required for a hurricane. If you, in fact, we'll talk later, but if you have winds aloft that are relatively strong, if your jet stream can kind of screw up that building high, which is required for a hurricane. So the cool thing then up at upper elevations, since you have a high, you're going to see movement clockwise instead of counterclockwise. So it's kind of a cool thing. And then around the eye, by the way, the eye then, like the slide says, basically, and I'm kind of getting ahead of myself, but that high pressure, one of the things is it wants to descend, okay? And that descending air will contract, and as it contracts, it will adiabatically warm, because work is done on that parcel of air. So it's kind of strange. If you've ever watched the movie The Day After Tomorrow, I know it's not entirely correct scientifically, but when the eye goes over these folks, both the father and the son, they're kind of like, oh, dang, because after the eye becomes more of the eye wall, this intense part of the hurricane. So kind of got a little bit ahead of myself, but let me see if I can do this. Oh, good. So you see what I was talking about. Here is the eye, and here would be a low pressure, and then there's a high pressure building up here. So at the high, we have actually anticyclonic movement, and down here around the low, we have cyclonic movement. So you're going to see here in a minute, and it's Hurricane Fran, basically the isobars. And we know that if isobars are really tight together, that means you have a steep pressure gradient. Drastic difference in pressures as you go just a little bit of ways, and we know that that is intense wind. So honestly, around the eye, that's where you're going to get your most intense wind. So let's see, this one down here, I don't know if you can tell, but this right here, this region right here, where the wind speed, the red line is the wind ramping up, and then you get the eye and there's no wind, okay? And then what's happening with regard to this real data that was collected is it's an anemometer reading the wind speeds, and then after the eye passes, they get the other part of the eye wall. So that's kind of what that's showing. And shown here also is a dip in pressure where the eye comes and then the pressure ascends. And actually, notice that the pressure, this low right here, the center of the eye, was 964 millibars, and that's really pretty darn low. And how low that central low pressure is for a hurricane or tropical cyclone is an indication of the strength of the tropical cyclone. I thought I had one more build, but I guess not. So up at upper elevations, they call that outflow. And honestly, so when we see, I think this is right, well, no, I can see it. When we get an aerial image of the clouds associated with the tropical cyclone, actually you're seeing both the spiral rain bands down here and then a little bit of the outflow up there. That's kind of the fuzzy part. So this just kind of, again, says that where you have that high pressure, okay, it's going to go from high to low, not to mention you have converging air here because of your low, okay, and that's why you built the high, but that air will want to, from aloft, over top of the eye will want to descend, and it will be squeezed, and so work is done on it, and it will warm adiabatically. Oh, there it is. This is I think this is neat, where it's showing you, again, you can kind of see the cyclonic movement down below and the anticyclonic movement up above. So just a little bit more, another slide about the hurricane eye. You know, how large is the eye? And here it says about averages 20 miles. So you figure if this is you and your eye, your whole hurricane system is coming at you, basically you're hit by the eye wall, then you get the eye, and then you get the other part of the eye wall. And think of the eye wall as basically a cluster. This is the way I think of it. We've talked about thunderstorm cells in here. Think of the eye wall as basically a cluster of thunderstorm cells. So as we've been talking about kind of the eye of the hurricane, what you're looking at here are isobars, and actually this is a surface map. And so kind of from left to right you can see, or I think it would be left to right from your view, you can see how Hurricane Fran went from being kind of a tight pressure gradient as it was over the oceans, a mature hurricane. Actually, it moved northwest, and you can see then that as it moved over land here on the right, that it was downgraded from a hurricane to a tropical storm, Fran, and then can you see there actually the central low was 980 millibars instead of the central low being 954 millibars. And can you see the winds lessened and all that? So actually you're kind of seeing a tropical cyclone or Hurricane Fran being downgraded, or kind of, it loses its energy as it moved on land.